Okay, good afternoon. So let's start the class. So first of all, announcement. So just to make sure that everyone remember this. So we will have our first exam next Tuesday, and then the scope will be everything that we have taught until now. So it is basically about the assignment 1, assignment 2, lectures 1, 2, 3, 4. Is that okay? So this is it. And then, okay, on Thursday will be the deadline of this assignment 2, and then Simon will give you the answer, a suggested solution of this assignment 2. And today, okay, so let's get back to the lecture. So today we will give more examples on this integer partitioning. And after that, then we have ended the whole discussion on generating functions. And then we will start something new. We will talk about recurrence relation. Okay, so let's do this. Okay, so I hope you still remember, okay, that we can use generating function to solve integer partition problem. And then we can actually use the equivalence of the generating functions to show that some different ways of counting integer partition are actually the same. So last time we have one example, and today we have 2 more. Okay, so let's take a look at this one. So first of all, consider this thing, 1 minus x. Let's multiply this with 1 plus x squared. And then multiply this with 1 plus x to the power 4. And then, let's start with 1 plus x. And then 1 plus x to the power 2. And then 1 plus x to the power 4. And then 1 plus x to the power 8. So we will have 2 powers. All of them, the power here of x is going to be 2 powers. So 16 and so forth. Okay? And we want to find out what it is. So let's take a look. Okay, so this will be equal to what? So if I multiply 1 minus x with 1 plus x, then we will get what? We will get 1 minus x squared. And then these 2 terms will be cancelled and combined into this single 1 minus x squared. And then for the remaining, we will copy it. So we will have 1 plus x squared, 1 plus x to the power 4, 1 plus x to the power 8, and so on. Is that okay? And then these two terms will then further combined become 1 minus x to the power 4. Is that okay? And then after that, we have 1 minus x to the power 4. It will be further combined with 1 plus x to the power 4. It becomes 1 minus x to the power 8. Is that okay? Okay? And then what will happen? What will happen? If you just stop here, let's take a look of this one. You will see that what is the constant term of the whole thing? If we multiply them together, the constant term will be equal to 1. Am I correct? So it will be equal to 1. And then do we have any x term? No, we don't have any x term. If you look at it, this is 1, right? And then all the terms that is after that related to x is at least x squared, x4, right? And then this term, this is minus x squared. So if you multiply with anything, the power will be at least 2. So you don't have any x term. Is that okay? So that's 0x. You don't have any x term. Is that okay? Now, imagine when we combine these 2 together, it becomes 1 minus x to the power 4. Then we also discover that you can't have any x squared term. You can't have any x cubed term. Is that okay? Yeah, because it is 1 minus x to the power 4 already. And then if you look at this, it can go on forever. So it is going to be 0x squared, 0x cubed, 0x4, and everything 0 all the way. So it means that this is going to be equal to 1. Is that okay? Does that make sense? Yeah, this is going to involve infinite number of terms. But then if you try to multiply them together, then you have only just 1 there. You cannot have x, you cannot have x squared, you cannot have x cubed, you cannot have x4. So it is going to be 1. Is that okay? A little bit hard to imagine, but you can also think about this as, if we stop here, we just have 1 minus x squared, right? If I stop here, I will just have 1 minus x4. If I stop here, I will just have 1 minus x to the power 8. So anytime we stop, you don't have x, you don't have x squared, you don't have x cubed. And if I try to multiply one more term, then you will see that more terms will become 0. Is that okay? So this is the observation that we need. So this is going to be equal to 1. Okay? Now this is our main character here. I'm sorry. So what do we have? Okay, so we have two ways to interpret this. Okay, so the first way is, let's do this. So you have this one. So this implies what? This implies 1 over 1 minus x is equal to 1 plus x times 1 plus x squared plus 1 plus x to the power 4 plus 1 plus x to the power 8 times 1 plus x to the power 16, and so on and so forth. Is that okay? Now this is the first way to interpret, and then what is 1 over 1 minus x? 1 over 1 minus x is equal to what? This is equal to 1 plus x squared plus x cubed plus x4 plus so on and so forth. Is that okay? Okay. Now think about them as counting problem, generating function of how many ways of doing something. So here, it means that there is one way to have 0 objects selected. There is one way to have 1 object selected, one way of 2 objects selected, one way of 3 objects selected, and so on and so forth. Okay, and how about this one? This corresponds to, for this one, I'm going to select 1 apple or no apple. Each time, I'm either selecting 1 apple or no apple, 1 or 0, 0 or 1. This means that each time I'm selecting 0 apples or 2 apples. Is that okay? And for this one, each time I'm going to select, if I'm selecting this, I'm selecting either nothing or I'm selecting 4 apples at the same time. Is that okay? So what does that mean? Okay. What's that? So here, if you look at focus on the right hand side, what is the coefficient of x to the power r counting? So this is the generating function, right? What is the coefficient of x to the power r counting? What does that mean? So first of all, I can select 0 or 1 apple, 0 or 2, 0 or 4, and so on and so forth. Is that okay? The coefficient of x to the power r, it must be the number of ways that we can select exactly r apples, such that what? Such that from the first part, I can select 0 or 1. From the second part, I can select 0 or 2. From the third part, I can select 0 or 4, and so on and so forth. Does that make sense? Is that okay? Is that okay? So this is like, so there is a box here. There is a box here. There is a box here. Okay. And there is a box for this one. So the coefficient of xr corresponds to what? The number of ways that each box I can do some option. For this box, I can select this, or I can just ignore this. For the second box, I can select this whole thing together, or I can skip this. For the third box, I can select this whole thing together, or I can skip this. Is that okay? Okay, so the number of ways to do this selection, this is exactly equal to what? This is equal to the number of ways to partition R into distinct 2 powers. Is it okay? Does that make sense? Yeah, so this is going to be, this question mark is going to be this one. And now, if you compare this one, because this generating function is the same as 1 plus x squared plus blah, 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 blah. So we know what is the coefficient. This coefficient is equal to, what is this coefficient? Yeah, what is this part? It is equal to, what? The left-hand side is equal to the right-hand side, right? So what is the coefficient of x to the power out there? 1. So it is equal to 1. What does that mean? That means that every number has a unique way to factor to be partitioned into distinct 2 powers. And it is what we know, okay? Right? For 3, it is sum as 2 plus 1. For 7, it is 4 plus 2 plus 1, right? For 16, it is 16. Is that okay? So every integer, every positive integer, or every integer greater than or equal to 0 has exactly one way to be written as a sum such that each part is a 2 power and then no 2 powers is repeated. Is that okay? If you are okay with this, could you please raise your hand? Okay? Good. Just make sure you understand things. So we can do something similar. Let's do something similar. So let's do this. So let me ask you, what is this number? 1 minus x. What is this number? Is it 9? 1, 2. Yeah. Let me double check. Yeah. Excuse me. Let me make sure that I'm doing something correctly. Yeah, let's try this. What is this? Should I add x to the power 10 here? Yeah, probably yes. Let's add x to the power 10 here. Yeah, what is it? Minus. Eh? Let me see. Let me double check if I'm doing something correct. So yeah, maybe no 10. Yeah, let's stop here. Yeah. So what is? Did I make a mistake here? Let me see. 1. Yeah. So what is the value of this one? 1 minus x multiplied with 1 plus x squared plus x cubed up to x to the power 9. What is it? Yes, very good. So this is equal to 1 minus x to the power 10. Am I correct? Is that okay? And then let's do something here. So let's do something like this. 1 plus x to the power 10 plus x to the power 20 plus x to the power 30 plus x to the power 90. What would that be? If I further multiply this, this will be equal to, what would that be? So you will have 1 left, right? And then you have minus x to the power 10, but then you have plus x to the power 10, it cancels. And then you have minus, and then what? And then you have minus x to the power 20, and then plus x to the power 20, and it cancels, right? So it becomes what? It becomes 1 minus x to the power 100. Am I correct? Does that make sense? Okay, and then if I do something more, so this time you guess, then I will have 100 here, 200 here, 300 here, up to 900 this time. This time x to the power 900. Then what will I have? Then I will have 1 minus x to the power 1000. Is that okay? So I can do something more, so you can see the pattern. So this time, this is just 1, 2, 3, 4, 5, 6, 7, 8, 9 times 1, the index. Here it is 10, 20, 30, up to 90, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 squared. This is going to be 1, 2, 3, 4, 5, 6, 7, okay, times 10 to the power 1. This is 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the power 2, and so on and so forth. Okay? So again, if you use our understanding, then this will be equal to what? 1. Very good. So this will be equal to 1. This will be equal to 1. So if we divide 1 minus x on both sides, then I will get something similar. So I will know that this is true. 1 over 1 minus x is exactly equal to the product of this one. Is that okay? Is that okay? So the right-hand side corresponds to what? Corresponds to, I have a box here. I have a box here. I can pick 1 apple. I can pick 2 apples. I can pick 3 apples up to, I can pick 9 apples. Is that okay? So I can pick 0 up to 9 here. For this one, this corresponds to a second box. I can pick 10 apples. I can pick another 10 apples. I can pick another 10 apples up to, I can pick up to 90 apples in total. Is that okay? And then the third part, 100, 200, 300 up to, so I have a lot of 100, and I have 9 of them. I can take at most 9 of them. Is that okay? So coefficient of x to the power r. So what does coefficient of x to the power r mean? So it is equal to the number of ways to partition r into integers such that you can pick 0, 1, 2, 3 up to 9 from this one, 10, 20, 30, 40 up to 90 from this one, and so on and so forth. So in other words, what does that mean? Such that, so if I have 3,000, and so let's say r is equal to 3,251. So what does that mean? So that means that in the first bucket, I must be picking exactly 1 apple, because in all the other boxes, it is at least 10. So I must be picking exactly 1 apple there. And similarly, I must be exactly taking 50 apples from the second box. Is that okay? And then I must be picking exactly 200 apples from the third box. And then I must be picking exactly 3,000 apples from the fourth box. So it is, so the coefficient, it turns out to be 1. The reason is that there is exactly one way to decompose a number into the decimal system. Does that make sense to you? Is that okay? The number of times that you are picking in the kth box, let's say this is the 0th box, first box, second box, third box, exactly corresponds to what is the digits, the kth digit in your number from the decimal system. Is that okay? And then it is exactly 1. The reason, if you look at this is the same as 1 over 1 minus x, the same as before, which is 1 plus x squared. So every coefficient is exactly 1. Okay? Yeah, I hope you like it.